Hi guys, I'm back and welcome to the stream. In this video, I'm going to try to understand time lock from within this Solady, which is like the super optimized version of a time lock. Um, and this is this is the most difficult series that I am doing till now. Although I haven't done too much, so it's like not really fair to say too much difficult, but it is really difficult because of the complexity involved. Since majority of the like code here is assembly, which is like the lowest level of writing smart contracts, and it's very complex in a way that we are playing around the memory and everything by ourselves. So this is the reason why I really find it tough, and I think that's enough, and let's just start reviewing the time lock contract. So let's just read what it say. So I'm not pretty sure what is this uh, ERC. I forgot, like, how do I need to mark comments? Was like this. Okay. Okay, maybe. So I don't know what is ERC style execution. Oh, this is so cool. Yeah, it is included in a specific way. Okay. So I actually saw I think, yeah, it is here. The proposer ID is given. Also not. No, actually not. So let's just understand. I'll just use Anara, by the way. So ERC 721. What is it? Give me a TLDR. And what the fuck is going on? I'll just cut off. Sorry, I'll just. Let's just review what it is, so we better understand like a couple of things. So ERC 7829. Oh, I did not see. Is it within the? Why the hell I'm not seeing it? ERC 7821. Here it is. Oh, okay. Oh, it is there. 781 781. I don't see. Okay, never mind. So it basically is consisting of executions, and that's it. Okay, let's just go here and then we'll see later on. So this implementation using enumerable roles for better audibility, and it's being imported here. And by the way, let's just start with here. So it's importing 721, which is like here mentioned here. Lib ERC 7529, which is library for handling ERCN 579. I don't know. Oh, okay, sorry. this only. And it's, I think it's a library for decoding certain things. Okay. and we have enum roles. Okay. uh Execution data can be encoded. Okay, execution data can be encoded in 3 different ways. A by encode the calls, A by encode the calls, and A by encode the predecessor. So predecessor is the last proposal that was being in the queue or something like that. I forgot. So that is that. And with salt, and where calls is a type is of type address, uint and bytes array. So where call is and taking give, we are taking address, uint and bytes. I think it is because we are like executing let's see. And precise the idea of the proposal that is required to be already executed. Okay, if predecessor is byte 0, it will be ignored, treated as it is not required. The optional sort allows you for multiple proposal. Optional sort allows for multiple proposal representing the same payload. The proposal ID. Okay, let's just try to understand it by like I'll just create another section specific to the time lock here, and I'm gonna put title time lock. I can do that. Yeah. So yeah, just a second. The proposal ID. Yeah. So call is of type this. Let's just take a note of this. Oh, I don't know what is wrong with my internet. It's so shitty. Yeah. So I'll just move it here, and also I'm writing that calls is type of if I can do that. Oh my god, don't do that. Yep. So I'm not sure what's wrong here. Yeah. And Mr. Iceman, thank you for Mr. Iceman, thank understanding for Mr. Iceman, thank understanding. Nakul bhai, thank you. I hope our debugging session is going good. Thank you, both of you. Yes. See you soon, guys. So call is of type here call is of type address uint and bytes array, and if predecessor is byte 0 it will be ignored, and the salt is for executing proposal with the same payload. The proposal ID is given by keycheck of mode. I don't know what it is, and execution data, so I'll just take a note of that as well. What is it? The proposal first proposal ID is given by, I can do this. So proposal ID is given by the keycheck hash of mode and execution data. Execution data is basically this. So I'll just, not sure what's going up here. So execution data is this, and I'll just make it red. Wait a second, execution data now. Yeah, so we can do this. Yeah, so proposal ID is fetched by the encoding of mode and execution data, and execution data is basically, sorry, so proposal ID is basically hash of mode and execution data, and execution data is basically encoding of calls which is address uint bytes etc. Okay, and we recommend including salt even though it is optional. Convenience, supported modes is support optional, byte support optional of data, where operator is AV encode. Okay, modes is basically a way to tell whether the predecessor is required or not, where we read it earlier as well. And is the remaining 25, which can be anything. For ease of mind, just use 2 and Okay. Okay, gotcha. And there are like four different roles defined. This role cannot directly propose or cancel. Propose, execute, or cancel. Okay, directly propose, execute, or cancel. This role is not exempt from the execution wait time. Okay, so this role is basically in like, even though it is admin, he will be waiting for the execution time, and also he does not have the ability to propose, execute, or cancel. Proposer role is the role that can propose operation, role that can execute or executions, role that can cancel proposed execution, and the maximum role. Like, there are like four roles. I'm not pretty sure like why there is a like a constant maximum role. Yeah. Not sure why there is a max role here, and assign this holder to a role. The function assign this holder to a role to allow anyone to call the function guarded by only role or open role. Okay, so we can assign this holder to a role, and which will make it public. Interesting. And this is an enum which defines the state of an operation. So we'll skip errors because we don't really want to review them. And let's go to storage. The storage slot for the time locks minimum delay. Okay. Oh, we are talking about this, right? So so we have talked about the calls, which is like the data, like for the execution, and we have also talked about the predecessor. We have talked about the proposer ID, how we are going to get the proposer ID for a given call. Yeah. Okay. So once that's done, uh, the storage slot for the time logs minimum delay, we restrict the minimum delay to be less than this, which is the max value of u into 56, sorry, and store the, no, this is, okay, why 256 minus 1, okay, so we are deliberately removing 2 bytes, sorry, bits, and store the, this has to check if it has been initialized via non-zero check. Let's just, I don't understand this. Oh my god, don't do that. Was it? There it is. And the cap. And storage 2's component complement negative value instead of the raw delay. Okay, okay, gotcha. Slot of operation, uh, slot of, just a second, proposal idea. Slot of operation ID is given by, we are like storing time, like times, wait a second, store offset, this is the offset, and memory, and we are storing time log slot, slot, we are storing the time slot value here, and then we are storing the ID, operation ID slot would be, since we have both, right? is, then we are doing a check on both of them. Bits layout is 0 10. I don't understand this bit, what it is referring to. Okay, so we are like calculating the operations ID slot by doing a check of time slot and the ID, and I think we'll get to know it later on. Okay, let's move ahead. And for guarding initialize if not via delegate call, we are storing the address of the time lock itself. Initialize if delegate call. Okay, for guarding initialize if not via delegate call, time lock deployer is the message.sender, and is it immutable? Yes. And the initialize time lock deployer origin is that the EOA, that is like, or the first initialization, who initialized it, initialize the transaction. And then there are like couple of events. Okay, and then we have what is it, event proposed event signature. Okay, now let's review the code for initializing the time lock. So it is taking couple of arguments here, initial minimum delay, initial admin, and is it part of this? Okay, yeah. So next we have some arrays which are addresses of proposers. What are proposers we want, executors and cancelers. So we are taking roles data as well as initial admin and also the initial delay. So first of all, we are calling the initialize time lock authorization check. So I think this should be because like if it is authorized previously or not. Let's understand. The time lock is best used via minimal proxy. The time lock is best used via minimal proxy. Not sure why, but in case it is not, we want to guard initialize from front run griefing. So that's a good question. Like we can deploy one thing. Okay, how is question is, how is proxy helping in case of front run griefing attack? I think when you deploy a proxy, I think you can just, whenever you're deploying, you can like multi-call it, right? But I'm not pretty sure how it is, but never mind. Authorizing both message sender and key. Authorizing both message and caters to the use where time log is being deployed. See, always call initialize as soon as possible after deployment. In the rare case of message sender transaction are untrusted and abused to front run, initialize will revert on reinitialization. So you will know that deployment is compliant must be discarded. So we are taking the self address, the deployer. I think deployer is basically the message sender, okay, and origin is that. We are checking if the address which is currently executing the code, which is the time lock itself, is the same as which was saved right at the time of initialization or deployment basically. And then okay, and then we are checking the origin. Sorry, here we were here, and once both are same, like the code that is executing and the code that when the address that was saved into the storage at time of deployment same, then we'll execute this, which is basically doing so we'll go from here. So if the caller get the caller, so the caller who has initiated the transaction is same as the deployer origin, like the one who initiated the transaction. And also we are checking if the deployer was message sender is same as the one who's calling. So the person who initialized the transaction and the person who is the current caller needs to be same, right? And we are doing the OR. So for those of you who does not have an idea of OR, so it works like this. So if one bit of operands is 1, then the result will be 1, right? So in this case like 1 1 will be 1, right? The result will be 1, which is true. If 0, and then we check like this should not be passed here, like we will not be going here. What is it, by the way? Okay, time log unauthorized. So so it's basically a check. It is basically a check where we are checking whether the transaction.origin and the message.sender is the same as message.sender. So it's coming out of the same user. Yeah, so we are doing that, and then we are moving forward. It is what is it? Sorry, logical right shift operation. Okay, so we're shifting right, but like whenever I am reviewing assembly, right? So majority of the time I don't really understand what is the purpose of like right shifting here. So I think it is basically so let's understand like how much initial, what is the max value of initial minimum delay. We just okay. So minimum delay has to be less than 254, and when we convert 254 divided by 8, it should be 31.5. It's not exactly. And what is 254? So So we are taking 2 bits out to save, I think. Yeah, so I think what we are doing is that whatever you provide in the initial uh, value, right, initial minimum delay, it's being right shifted. So like the lowest bit gets cut, sorry, yeah, the lowest bit gets cut off. And uh, I think that is it. This should anyways pass, right? What? I think this is when we are loading. Yep. So I think what it is doing is let me like if we pass something like 2 3 4, right, then it is what it is doing is right shifting. So it will become, sorry, one more and 1 2. I think this is what it's happening. And yeah, that is, and then it's reverting. If the result, let's just see. What the hell? Shifts the value right by 254. Shifts the value initial whatever the user provides to 254 bits right. If any bit in position 254 255 was set to 1. Okay, wait a second. So if we are shifting the initial mandate to 254 bits right, and if whatever the result is, it's more than that, if then it will revert. Okay, got it. Okay, and then we are loading the time lock into S, and time lock is basically what was time lock, by the way? Forgot. Time lock slot is basically minimum delay. Yes. So we are checking if this is load, it will return true or false, right? Yeah, so if it is true, if it's true, then we are reverting with already initialized. If not, then we are moving forward with by store, like calling as a store, which saves something to what the word basically to the storage, and we are doing not basically flips the bits, right? So when we are doing a store, okay, I think it's like flipping the bits here. Does it flip bits and converts positive number to negative? No, the bits are not all bits flipped in minus d plus 1. Okay. To record original delay and to use 0 as the. Okay. We are storing it, and then we are storing it to memory for this logging, and we are checking if initial is not. If initial is true, we are not setting the initial admin. If the initial is not 0, then we are saving, like giving the initial admin the admin role, and then we are like bulk setting the other roles. And how does it work is it like part of this contract? Yeah, it's part of that. Okay, we'll go through it later, and let's move forward. So we have covered like how would the initialization works. Yeah, So yes, so the time lock is, so we have already gone through here. Let's review public. And by the way, just give me a second. It's not okay. We'll go here. Propose and execute. Proposes and execute payload mode, which is, I said, either could be uh, the one with nonce, non, was it nonce or something like that? Yeah. So with that, and the execution data with delay, propose a role. So we are checking. I think it should be also. Oh, it's not. This is so cool. Finally, we have something which is not written in assembly. Oh, it is actually written in assembly. Okay. So yeah, so we are taking three argument from the user here. The first one is the mode, the second is execution data, the third is the delay. Okay, and that is only proposed by the proposer role, and in exchange we'll give, the contract will give back us the id of the proposal, I guess. Yeah, so we are calling the library decode batch and op data, which takes execution data, and let's see what it does. Decodes a batch and optional data reverse if execution is not okay. We'll just skip it. And minimum delay, I think it should be loaded from the memory, which is here, yeah, which is true. And then we are going into assembly again, my boys and girls. Yep. So what we are doing is that we are shifting right and reverting if the delay passed by the user is overflowing, which is like right now we are accepting only 254 bits, leaving the last 2 bits for negative. Yeah, so now it's working. 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 Yeah, this is how cool. So let's go ahead and we are checking if the delay is less than the what we have saved, and it'll basically revert. So it's basically checking something like it's doing like delay should be greater than, like, checking that delay should be greater than minimum delay, and then it's loading something from the free memory pointer. I don't know what it is. Whatever it is, right? The free memory pointer. I think it's writing to the next available uh, free memory space. Like M defines the free memory, and it's like copying the data, copying the call data, which is execution data. What the fuck is offset? What is offset? I don't know. Offset, is it something like within I think it should be yeah, the length and the offset, but I'm confused there, since what is it doing, right? It's what is it doing? Yeah, so it store the bitwise not. Bitwise not, by the way, is like both the, if both the bits are ones, then it'll be the same, else not in the time lock slot. It store the bitwise not of initial mini. Wait a second. Initial minimum. Okay. Yeah. So what it is doing is that it is store the bitwise not of initial in the time lock slot and to receive bits. I don't get it. What does it do? Yeah, I think this is way better. Oh yeah, for sure. This is like doing the same. Oh, I did copy the wrong lines. My bad. Those two lines are preparing data in memory to derive the proposal ID. Call data. We are adding like 80 bits to what the memory pointer points to, and then this is a copy data sorry, bytes from call data into m plus 0x, where m is the free memory pointer. Yeah. Okay, and then what is mode here, by the way? And it is writing mode to the offset 0. Yeah. So we have copied the execution data in the memory, right? So far we have, like, I'll write it here, storing execution data in memory, which that is free memory pointer plus 0x80. And by the way, for those of you who don't know, I'm including me, is 128 bits. Which is 16 bytes. And then we are storing the mode details in here. Saving mode data to memory offset plus 0. By the way, this is like 32 bits, so we are writing 32 bits of mode, so 32 bytes, my bad. Oh my god. Yeah, and then we are deriving the id from set 0, where we stored the data of mode offset, and what is the size, and 0x40. Since the data is for memory pointer plus hex 80. Oh, okay, sorry. I forgot to read this line. And what it's doing, it's saving it's saving the k check of m. M was again, what was m? Oh sorry, free memory pointer 280. So we are calculating the offset here, which is free memory pointer to the end of our execution data, and then we are giving it the size, and we are storing it at hex 20. So hex 20 to hex 40 will be the data for, so okay, got it. So this is id is being oh my god, generated by check of mode and execution data, which is correct. And then hex 09, why, what is hex 09, and then what is hex 20? Yeah, and then we are storing, we are overwriting. Why are we overwriting here? I'm not pretty sure. I'm not really good at assembly, right? But I'm trying my best. So and that 0x40 is, I think, supposed to be 64. Okay. And then what we are doing is that we are storing the time lock to this location and the id to here, and then we are doing 20 bytes and 9 bytes. Time lock and id operation slot. Okay, let's just write it, because I am pretty sure that I'll be forgetting it sooner or later. And then we are let me just store it. So we are doing two things. The ID is generated from here, then operation slot is basically generated from time lock slot, and ID of course is the ID of mode. Okay, so let me just create a screenshot of this. Let's put it here. Yeah. Yeah, so I'll just highlight some of the bits. Okay, here highlighter. Yeah, so we are generating the ID here. Also we are generating the operation slot here. So more hash, and then we'll generate, and the operation slot is being generated from here. Yeah, I think good enough. Let's move ahead. So we have we have stored so we have operation slot now. So operation slot will be the slot where the data will be saved, right? Yeah, and it's checking if true. So if the value of is stored on already, let's load store. Then we are storing more to the memory pointer, and then we are storing 60 by what we are storing m. We are adding, we are writing to 20 bytes data that in front. So we have written mode in the memory, and then we are I don't know what it is that we are doing. Deliberate plus timestamp, and so we are adding the current timestamp with the delay that the user provided, I guess. Yeah, and then we are storing it on what are the key and value. So s is the value, which is the operation slot, and we are writing the delay. And that's it, I think. Yeah. Okay, so what is going on is that we are based on the operation data, right? We are just saving what's the unlock period, what is the unlock time of an operation, and we are just saving it into the memory. We are not doing fancy things like storing a lot of data within a struct. Or operation slot is heavily dependent on the user argument, so it's it's impossible without having the exact uh, user data that led to the operation slot to be overwritten, right? So here we are just saving what is the unlock time, and we are just saving it into the memory. So here we are doing, and sorry, here we are updating the storage, and we are uh, no. So we have got the value for the ready timestamp, and we are storing into the memory. So S is the storage slot. We got somewhere here is the operation slot, and where were we? Yeah, and we are left shifting. We are moving from low bits to right bit. So we are removing the negative bit, I believe. Yeah, but what we are saying is exactly exactly that. Yeah, and then we are emitting some events. Okay, that's cool. Yeah, so basically this screenshot defines where the um, data is being stored. So for example, we are calculating the ID. uh, ID from check of mode and execution data, and then we are defining the operation slot by what was it? I forgot to write here. Say it is being generated by check of mode and data, and we are doing what was written here. Time. Oh, okay. So we are calculating the the operation slot by using the ID and time lock slot. Yeah. So let me just make a note of that. The operation slot is being determined based on operation. Sorry. What was it? Time lock slot. And the other thing was the ID. Yep, this is it, and I can just do it here. Can I do it here? Yes, I can. And also I need one more here. Yeah, and then we are simply writing to the where is it? As a store to the update the operation in the storage. Yes. Oh, okay. That was easier than like reading this piece of assembly was easier than what we reviewed for 7702 proxy, which was like, oh my god, that's too much. Is my stream going on? Yes, it is going on. Just a second. Yep. And let's move ahead. Cancel, right? And by the way, I forgot there is like a value of oh yeah, just a second. So we are saving just the times operation times update the operation in the storage, which is like updating the times now. We are doing something. Okay, let's understand the id. So id is something that we got from check of mode and execution data, so we must be needing the id. And okay, that was pretty straightforward though. Yeah, s is basically what is s? Check of operation slot, check of 0. Okay, so we have time slot and the id, and we are calculating the operation slot, and we are loading the data that is present in the operation, which is of course the unlock time, right? So if or 1 p, what the fuck is p? And is basically this is cool. Okay, so we are like cancelling by removing the timestamp data, which is pretty straightforward. But here what we are doing is that we are checking if these are same is 0p. So and is basically, no, we are doing and in p, right? 1 in p. So which will be, apologies. So we are doing and basically is if both values are 1, then it is 1, else it is 0, which is okay. So 1 and p is something bigger, which will definitely return 1, which is true, right? 1. And is 0p, if 1, the result is 1, which is true. No, that should not be. So first of all, we are checking whether the value at the slot is there, and like we are doing bitwise operation, so the result will be like it will be 1 only if the both like if the data is present, right? Which is 1 here, and 1 is an or is going to be 0p. Let's just simulate as in like if there is data, right? So 1 and p like we are doing 1 and p is greater, right? It is there, and it will be 1. So it will this operation will be 1, and is 0, it's not 0, then it will be 0, and 0 and 1 is 1. And if true, no, I think I messed up. Okay, let's just understand this condition. I can do that. P is the stored state for the operation ID. The check means and 1p is the cancel bit set. How are we doing that? Is 0. How are we checking? How are we checking cancel bit set? It would be with flags. Okay, my assumptions were wrong. So it's like the last. I was confused here. Like, I did not understand. Like, why are we comparing a single digit to a like the whole thing, right? So okay, we are just storing clears the operation slot. That's how we cancel. And how do we check for it? And first of all, we the thing here will be um, mm, so the thing here will be the maximum we discussed, right? It is 254. Yes, which is mentioned here. Should not be more than that. Caller is the address. If the caller who's calling is the user who's executing, how is this supposed to work? Yeah, yeah. Let's just understand this. So address is the get address of the current executing contract will be the address of this, and the caller is the caller. If but how is this condition going to be done? How is this condition going to be true since message.sender is going to be different than this? Okay, so it is only allowing the contract itself to update here. Okay, cool. I now understand. Makes sense. And we are checking if it is overflowing. And we are then storing the bitwise not to the time slot, which is the negative value, and then emitting. And these are like the view functions, right? So operation state, I don't need to understand that. Yeah, this is interesting. So let's understand this. We are loading into memory the time slot. We are loading the ID. But the ID we are now, wait a second, oh, this is confusing me, the math is confusing. So let's understand the execute updates the operation state. Doing okay, check. Is it compiling? Oh, no. So let's do this. src, oh my bad, src accounts, then it is extension, and it is time lock. My dude, no, wait a second, oh sorry, it's under account only, time lock, and then what we need to do is methods. Yep, and can I write that under method? Yeah, so we have it here. There should be another function, right? Yeah, so let's understand. Let's understand execute. So so far there was propose function that we reviewed, and also the cancel. Now it's time for us to understand this, but I'm curious to understand one thing, which is how do we actually call it? Is it this? Delegate call maybe? do we like? How are we even calling? Oh god, there are like too many call here. Executes the call here. It is this. Does not revert. Two variables. Okay, yeah, here it is. Which is calling. So it doesn't support delegate call, but the call itself. Yep. No, I understand. So let's go back and get back to understanding execute, which is the heart of the time lock. So we are checking if the caller has